Welcome to another lesson in the series. Today we are talking about the factor theorem. The factor theorem says if x minus a is a factor of f of x, that's a polynomial function f of x, then f of a is equal to 0. So here we say a would be a root of the polynomial. In other words, if x equals a is a root of the polynomial function of where f of x is equal to 0. So if you plug in some a here, the 0, then x minus a is a factor of the polynomial. All right, so let's look at an example. Given the polynomial f of x is equal to x cubed minus 6x squared plus 11x minus 6, determine if x minus 1 is a factor. The solution here, x minus 1 is equated to x minus a, and so by matching a will be equal to 1. Conversely, you can use algebra to work this out and still getting a equals 1. A third way would be just thinking of x minus 1, setting x minus 1 equal to 0. Adding 1 to both sides and you get x equal 1. So either way, we are going to plug in 1 into the original equation. So we're going to substitute 1 then into the original equation f of x. So we're talking about f of 1. So we replace x with 1 or substitute 1 for x. So we have 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. And so this becomes 1 cubed is equal to 1, 6 times 1 squared. That is 6, so 1 minus 6 plus 11 times 1, that's 11. So that's plus 11 and minus 6. And then if you plug this in your calculator, you will get 0. Or you want to do it step by step. 1 minus 6, that's negative 5. Plus 11, that's positive 6. 6 minus 6 is equal to 0. So since f of 1 equals 0, then x minus 1 is a factor of x cubed minus 6x squared plus 11x plus 6 by the factor theorem. So that is how you show that an expression is a factor of a polynomial using the factor theorem. Example 2, we're given that x plus 2 is a factor. So we're told that it is a factor of this polynomial 5x squared plus bx plus 36. We don't know the value of b, so we want to find the value of b. So what do we know? We know that x plus 2 is a factor. So let us find what we are going to plug in. That is, what is our value of a. So we say x plus 2 is equal to x minus a, and simplify to get what a is, or solve to get what a is. So a will be equal to negative 2. So what do we know? If x plus 2 is a factor, so the f of negative 2 would be equal to 0 by reason that x plus 2 is a factor. So if x plus 2 is a factor, then the f of negative 2 is equal to 0 by the factor theorem. Now we still want to find the value of b. So what we want to do is that we're going to substitute negative 2 into f of x. And if you substitute negative 2 into f of x, you have f of negative 2 is equal to 5 times negative 2 squared plus bx plus 36. But we know that f of negative 2 was equal to 0. So then this trinomial here, this term 5 times negative 2 squared plus b times negative 2 plus 36 equal to 0. We should have substituted the negative 2 up here as well. So up here should be b times negative 2, but that's fine. We did it here. And then we're going to simplify and solve for b. Negative 2 squared, that's equal to 4, so that's 5 times 4. Plus negative 2b plus 36 equals 0. So 20 minus 2b plus 36 will be equal to 0. Bring the like terms together on the left side. 20 plus 36 minus 2b equals 0. Then 20 plus 36 is equal to 56. So 56 minus 2b is equal to 0. We want to try to have b only on one side. So you could subtract 56 from both sides. So 56 minus 56, that goes. So only minus 2b is left on this side, the left side. And on the right side, 0 minus 56 is negative 56. We still have a negative 2b here. To undo this negative 2b, we divide by negative 2. We must do that to both sides to balance. So the negative 2b divided by negative 2 only leaves b. And negative 56 divided by negative 2 equals 28. So the value of b in this example is b is equal to negative, no, not negative, but b is equal to positive 28. Thank you.